Now we'll look at a topic that is not going to be used right away, but we'll certainly use quite a bit throughout this chapter. So this is something that you may have run into if you took a statistics course, which is a mathematical operation called a factorial. This is a recursive operation. It's used a lot within sequences, so certainly useful to introduce at this point. The definition of a factorial of some positive integer n, and these has to be an integer value, is whatever n happens to be, you put an exclamation after it to represent the factorial operation, and you just take whatever n is and multiply it by 1 less than that, 1 less than that, and keep repeating until you get down to 1. You multiply all these values together, and that determines the factorial. In addition, if you run into it, the 0 factorial is equal to 1, and that might actually just be a definition. I'm not really sure if it's provable, but if you run into 0 factorial, just remember that that's equal to 1. All right, so if we wanted to compute a factorial, say like 6 factorial, we would just start with n, which is 6 in this case, take 1 less than that, 1 less than the previous, 1 less than that, until we get down to 1, and then we multiply these numbers all together. And it might be useful to use a calculator in order to do the main grunt work here. So multiplying that all out, we get 720. Now, speaking of the calculator actually has a means of doing factorial. At least the TI does. If you put the number that you want the factorial of on the home screen, then go under the math menu, so press the math key. You come over here to a sub-menu called prob. Probably the 4th item down there is an exclamation point, which is the factorial. So you can get the calculator to do a factorial for you. You can also count on its recursive properties to help calculate these. So for instance, if you want 7 factorial and we just did 6 factorial, you can actually just multiply 7 times 6 factorial, which would be 7 times 720, and that might be faster than computing it outright. So we get 5040 as an answer here. And of course, we could have used the calculator to do that directly as well. Now, the thing you have to be careful of in the calculator is that these values of factorials grow very quickly. So like when you get to, say, 9 factorial, you get into the 100,000s. If you multiply that by 10, that would be 10 factorial. If you multiply that, then you're in the millions. If you multiply that by 11, it grows very rapidly. In fact, around 15 factorial, or maybe it's 13 factorial, I can't quite remember, it gets to the point where the number is so large that it has to switch over into scientific notation in order to work that out. And then by the time you get to around 70 factorial, I think it is, oops, I believe the calculator runs out of memory at that point and just can't compute those any longer. So you can't always rely on a factorial being able to be processed within a calculator, just because they get so large. So how in the world could we do something like C if we wanted 325 factorial divided by 323 factorial? Well, we just have to be a little bit more clever in the way that we go about computing this. So for instance, instead of typing in 325 factorial divided by 323 factorial and, getting a math overflow error, we could simplify first. So for instance, 325 factorial is the same thing as 325 times 324 factorial, just the same way that 7 factorial is the same as 7 times 6 factorial. Now, that might not really get us very far in terms of simplification, but if we repeat this process, we could say that 325 factorial could also be written as 325 times 324 times 323 factorial. Now, this is something that can really be helpful, because the thing is, 323 factorial, even though that's an extremely large number, it's the exact same number in the numerator as in the denominator. And all of these terms are multiplied, which means we can cancel through division. And so this is really just going to be found by taking 325 times 324. So if we go away from there, 325 times 324, there's 105,300. Now, there might be, like, some calculators will actually do a little bit of simplification for you. So there might be a means for the calculator to actually compute this value. Let's take a look. No. Okay. That's fine. So it's easy enough to see the simplifications that you can do here. And this brings up the important part of factorials that we'll use in the class. Generally speaking, we're not going to be needing to evaluate these things numerically. We're going to evaluate them algebraically. Now, there's not a lot of algebraic properties of the factorial that we can work with. However, this concept of basically taking the top number, okay, when I say the top number, I'm saying like this value here becomes the top number in the factorial. We can always take that top number times the factorial of what's left over, even if we have an algebraic expression like this. So n plus 2 factorial could be written as the top number, which is n plus 2, times the factorial of the remaining terms. Well, what's the remaining terms? Well, if we start with n plus 2, then n plus 2 is our top number. 1 less than that is going to be the remaining values. So 1 less than n plus 2 would be n plus 2 minus 1 or n plus 1. And that might get us to a point where we can do some simplification. Hopefully it will be some cancellation like we did in part C. If we're not there, but we can see another iteration might get us to a point like that, then let's do that. So n plus 2 is off to the side, it's just a factor now. Of this factorial, n plus 1 is the top term. So I'll pull n plus 1 off the top of this factorial, leaving me 1 less than that factorial for the remaining terms. And then I can see here there's an n factorial term that can cancel out of the numerator and denominator, allowing me to actually multiply these if necessary. So I could expand it into, say, n squared plus 3n plus 2, or leaving it in factored form is more advantageous to the problem, then I could just leave it in factored form. But the key to a lot of problems that we'll ultimately end up solving is this concept of canceling algebraically with factorials. That's the thing that you want to make sure you can take away from this part of the lesson.